Welcome to the universe of angles. Before we can understand the theorems, the relationships, the magnificent world of angle geometry, we must first understand what an angle is. An angle is formed when two rays emerge from the same starting point, called the vertex. A ray starts at a fixed point and extends infinitely in one direction. It has a starting point, but no ending point. Between the two rays lies the angle itself, and every angle has three essential parts: two rays and the vertex where they meet. The measurement of an angle tells us how far one ray has rotated from the other. We measure angles in degrees, with the full rotation being exactly 360 degrees. But why 360? The ancient Babylonians chose it because it divides evenly by 24 different numbers, making it the most mathematically flexible choice in human history. And there is a second, more natural language for angles: radians. One radian is the angle whose arc length equals the radius itself. Wrap that radius around the circle, and it fits exactly 2 pi times 2 pi radians, 360 degrees. The same journey, written in two different languages. Every angle in existence belongs to one of 7 great families. Let us meet them, one by one. At the very beginning of our journey, the zero angle, the angle of perfect stillness. Both rays point in exactly the same direction, overlapping completely. The opening between them is nothing. The acute angle, sharp, energetic, alive, from the Latin acutus, meaning sharp or pointed. Any angle greater than 0 but strictly less than 90 degrees is acute. There is an entire galaxy of acute angles, from the tiniest sliver of 1 degree to the clean 89-degree angle. Now, the most important angle in all of mathematics, science, and engineering: the right angle. Exactly, precisely, perfectly 90 degrees. Not 89.9, not 90.1. The right angle is the cornerstone upon which all of civilization is built. Every wall in every building, every street grid in every city, every coordinate system in all of science. And from this single angle is born the most famous equation in geometry: a squared plus b squared equals c squared. The obtuse angle, wide, powerful, dominant. From the Latin obtusus, meaning blunt or dull. Greater than 90 degrees but strictly less than 180. Where the acute angle is sharp and pointed, the obtuse angle is wide and spreading, like arms thrown open in welcome. The straight angle, perfect, infinite, absolutely flat, exactly 180 degrees. The two rays have become one straight line. And here is something profound. A straight angle is simultaneously a line, which means the two great concepts of geometry, the line and the angle, are actually the same thing at 180 degrees. Welcome to the secret of geometry, the angle most students never see. The reflex angle. We almost always focus on the smaller arc, but there is always a bigger arc on the other side. That larger arc, measuring more than 180 degrees, is the reflex angle. The shadow angle, 70 degrees plus 290 degrees equals 360. Always. And finally, the most complete of all angles. The full angle, 360 degrees, one complete revolution. Every full circle in the universe, the orbit of planets, the spinning of galaxies, the rotation of atoms, is a 360-degree full angle. When angles meet each other, theorems are born. When two straight lines cross, an extraordinary thing happens. 4 angles appear, and those 4 angles have a secret relationship. The angles directly opposite each other, called vertical angles, are always exactly equal. They are congruent. The supplementary angles theorem. 2 angles are supplementary when they add up to exactly 180 degrees. Think of them as 2 puzzle pieces that perfectly complete a straight line. The complementary angles theorem. 2 angles are complementary when they add up to exactly 90 degrees. The word complementary shares its root with complete, because together these 2 angles complete a perfect right angle. A ray standing on a straight line creates 2 angles. As one grows, the other shrinks, but their sum stays locked at 180 degrees. Always. The angle bisector theorem. A bisector is a ray that divides an angle into 2 perfectly equal halves. The word bisect means to cut into 2 equal parts. 2 parallel lines. 1 transversal. And out of this elegant setup emerges one of the greatest collections of angle theorems in all of geometry. Two parallel lines, cut by a single transversal, create 8 angles. 8 angles, 4 theorem types, and infinite applications. The corresponding angles theorem. Angles in the same position at each intersection are always congruent. Angle 1 equals angle 5. The alternate interior angles theorem. Between the parallel lines, on opposite sides of the transversal, these angles are equal. They form the famous Z shape. The alternate exterior angles theorem. Outside both parallel lines, on opposite sides of the transversal, angle 1 equals angle 8. And finally, the co-interior angles. Unlike the others, these are not equal. Instead, they are supplementary. They always add to 180 degrees. For theorems, corresponding angles are equal. Alternate interior angles are equal. Alternate exterior angles are equal, and co-interior angles sum to 180 degrees. The triangle, geometry's most perfect shape. The most fundamental theorem in triangle geometry. The sum of the 3 interior angles of any triangle, no matter its shape, size, or orientation, is always exactly 180 degrees. Watch what happens when we tear the 3 corners off and place them side by side. They form a perfect straight line. Extend one side of a triangle, and you create an exterior angle. That exterior angle is exactly equal to the sum of the 2 remote interior angles. 45 plus 65 equals 110. The isosceles triangle theorem. If 2 sides of a triangle are equal, then the angles opposite those sides are also equal. The base angles are twins. And the most perfect triangle of all, the equilateral triangle, all 3 sides equal, all 3 angles exactly 60 degrees. Perfect balance, perfect proportion, perfect symmetry. The circle, where angles dance in infinity. A central angle has its vertex at the very center of the circle, and its measure is exactly equal to the arc it cuts out of the circumference. But move that vertex out onto the circle itself, and something remarkable happens. The inscribed angle is exactly half the central angle standing on the same arc, and when that arc becomes a full semicircle, the inscribed angle is always a perfect right angle. This is Thales' theorem. Leaving flatland, angles in the 3rd dimension. In 3 dimensions, angles no longer lie between 2 lines. They live between 2 planes. This is the dihedral angle. It is measured in the plane perpendicular to their line of intersection, and it can be computed from the normal vectors of the 2 planes. For a cube, it is exactly 90 degrees. For a regular tetrahedron, about 70.5 degrees. And there is one more. If a plane angle measures the spread of 2 rays, a solid angle measures the spread of a cone in 3 dimensions. It is measured in steradians. And just as a full circle contains 360 degrees, a full sphere contains exactly 4 pi steradians. Every theorem we have learned is a star, and together they form a constellation of mathematical knowledge. 17 theorems, one complete map of the angle kingdom. Every angle you've seen today is not just a number, it is a law of the universe. The bridge holds because its engineers understood angles. The satellite finds its orbit because its navigators calculated angles. The artist creates beauty because the eye perceives proportion. You came here today as someone who knew angles were measured in degrees. You leave as someone who understands that angles are the language in which the universe writes itself. And now you can read it.